Inspiring on the guidelines provided by the handbook written by members of the United Nations task team on satellite imagery and geospatial data, we at the National Institute of Statistics and Geography have been building and deploying our strategy for garnering and exploring Earth observations to produce new experimental products that we are already publishing as part of our information offer and research production. Also, for our progress, it has been critical the collaboration with members of the task team, particularly with colleagues from Geoscience Australia that shortcut our course for the appropriation and application of the Open Data Cube technology. Briefly, we report our results in the generation of national products taking advantage of Landsat Image Archive. This imagery has been stored, managed, and processed with our own installation of the Open Data Cube technology, called the Geospatial Data Cube of Mexico. With this technology, we have developed new geospatial data products such as Geomediana Landsat, that is a valuable input to apply machine learning techniques, and also the ICASE Landsat, that is the result to apply a classification method for the identification of water from space. Also, we have undertaken data science and machine learning applications with a focus on the production of useful information to track the SDGs. Particularly, we're working on identification of urban settlements, detection of vulnerable settlements, tracking the certification, and cropland border determination. Geomediana Landsat is a collection of 31 national mosaics for the Mexican territory. Each mosaic is the result of the Geomedian composed method over images taken from a period of time, normally a year. The result is a continuum national mosaic that summarizes what is observed nationwide. The user can explore and compare these distinct Geomedian mosaics by visualization tool in our site. Also, can download the files with 6 bands images. Another interesting product is the ICASE Landsat. The name ICASE is for the Index of Classification of Superficial Water from Space. This product is a collection of national mosaics that results of applying a pixel classification method very similar to the one proposed in the WOFS methodology. The classifier looks for the presence or absence of superficial water. The index is the percentage of the incidence of water in a given period of time. In the image shown in the slide can be observed the comparison of 2 years in the Mexican state of Tabasco. In 2020 year, Tabasco suffers from a flood due to unusually heavy rainfall. This can be observed in the ICASE layer. One of our first applications of data science and machine learning on Earth observation at a national level is for recognizing urban growth. To identify human settlements, we consider the address numbers database. This database was built with address records and was last updated in 2012, when there were more than 30 million addresses numbered over all Mexican territory. A 1 square kilometer grid is defined over the country, and the addresses density is computed for each cell in the grid. By comparing the density distribution of the addresses number, it is possible to differentiate settlements with a high density of homes from those with lower density. With the application of machine learning techniques, it is possible to replicate the identification of these patterns from 2012 to the rest of the years. The region of El Bajío is a relevant example. Since the early 1990s, there has been sustained support in the region for the development of the automotive industry. In recent years, this region has the highest economic growth in the country. This is reflected in the growth of the urban areas shown by our classifier. This way, the predictions made by machine learning can serve as input for the generation of indicators that allow us to measure, among other things, progress on goals of sustainable development. This application is published in Earth Observations Toolkit for Sustainable Human Settlements. Recently, we have developed a deep learning application to identify regions of deprived areas or slums by analyzing Geomedian mosaics. This project is a collaboration with the National Polytechnic Institute of Mexico. Last year, We present a proposal to the GOGE program, and proudly we were one of the winning projects. Based on data from the National Population Census of 2020, Coneval, the National Council of Evaluation of Mexico, states that 17.9% of Mexican population live without access to essential services, and 9.3% live without quality and adequate space in their homes. Commonly, these people live in deprived urban areas or remote and isolated rural territories. Unfortunately, countrywide censuses are exercised done only every 10 years, which it makes difficult to track the short-term effect of policies to reduce poverty. This project takes advantage of machine learning and remote sensing methods to timely identify deprived areas. Here is a graphical summary of the methodology that we follow. Census data is associated with satellite image through residential blocks locations, construct machine learning algorithms training datasets. Then various deep learning architectures were trained and tested to get the best possible model for identify vulnerable settlements. You can find the details and the links to code and data in our recently published paper. Within these products and applications, we are taking a step forward in the strategic use of Earth observations for the production of valuable statistical and geography information. We hope you find it interesting and will be very happy to answer your questions. Thank you.